Okay, so back to, to chatting you guys. Okay, so one of the things you can also do is, like, if you want to practice debugging, right? So one of the things that I did to get good at debugging was to be a tutor at university. So I actually was tutoring our second year course, and so we had 250 second year students, and so I was tutoring them, and at one stage I was doing 24 hours of tutoring a week, which meant I was only a part-time student by that point. But yeah, so I saw a lot of people's code, and when you see enough other people's code, you get quite good at working out how to find errors, and that's more of the craft and art of debugging. The best ways that you guys can do that in your projects is to help each other debug the code you're writing, right? So don't just debug your own code, but learn to debug by helping other people debug their code, right? So as this debugging network code, debugging your chess problem would be something you could do. Now, if you have no friends, you could go online and use and do debugging of standardized debugging problems, right? Okay, that's a bit harsh. What I mean is, no, if you just want to practice some debugging and you want to kind of like practice your programming and your understanding, then there are plenty of online tools for an environment. So visual programming language. So if you go to the simplest end, you can look at this kind of Scratch debugging. And so you have the idea is, you know, there's a problem. This debugging challenge is week 2 activities for the Creative Computing Online Workshop. In this project, the Scratch cat teaches Gobo to meow, but when it's Gobo's turn to try, Gobo stays silent. How can you fix the problem? Right? And so there's a bug in this code, it's in Scratch, and so this is teaching people to code, not by telling them what things do and then getting them to put things together, but by showing them a lot of code that is almost correct, and then them learning how to code by fixing things that are almost right. Right? Now I've just this morning dropped off a bunch of electronics to the international school because they want the kids to take apart electronics. Right, just to see what, like, you know, what is made up of them. But one way of learning electronics is you get a whole bunch of working things, and then one bit is broken, and you have to take it apart and try and fix the one thing that's broken. Right? So not building from scratch, which we kind of teach you guys to do, but learning by fixing. So debugging can be taught, like coding can be taught from the debugging perspective first, rather than the principles position first. Right? And so this is an example in Scratch of doing that. Now I won't bore you with Scratch, but the other approach is you go to something like Coding Game, and it doesn't have debugging challenges, but it has text-based challenges that have test cases. And so initially all the test cases fail, and then you slowly work on making more and more test cases work, because it already has kind of a file reading and writing stub there that's just wrong. So have any of you got Coding Game accounts? One. Okay. Am I your friend on Coding Game?
Probably not.
Probably not. I think I can add you if I go to my profile, so I can go in friends. No, I didn't mean search all of my connections to find all of people who might be my friends. I meant to go and find. So I'm level 8. So this is the gamification of debugging. So of coding. So I'm level 8. Apparently, I'm okay at C++ puzzles. A little bit okay at C, and I've done a piece of cake. I got something done there, and some other stuff done. Right. So I did an ASCII art puzzle. So and I have you ever friends. I have 0 friends. I have 1 follower. Oh no, no, sorry, Morton232. That's my 1 friend. Maybe I should add more friends. But in here you've got practicing, competing, contributing new puzzles, right? New problems to solve. and a learning area, right? Now, one area that we're thinking of is actually adding content to here to help you guys learn to program by doing this. But and there are sponsored puzzles. I've not seen those. All right, they're sponsored by companies who Nintendo have a cryptology puzzle encoding game. So in puzzles, they get you learn languages and you learn to debug basically because there are test cases. The test cases fail, so you have to find the reason they're failing, and you have to fix those. Now there are, if I go into games, the one I said, like the ones I think are most interesting are actually the bot challenges, because they're an AI programming. I quite like AI programming. It's kind of fun. I've tried those two. I haven't tried these two yet. You know, I'm 211th isn't too bad in the wooden league. So here I'm in the gold league, so I got a bit better there. But coding golf, I think, is something you should avoid. So I did this one.
Yeah, that one's really boring.
Yes.
South, north, east, west.
Yes. So, but the problem is that you end up writing code that looks. Can I get rid of this window? Yes. Like this. That is bad.
There are a lot of points, so.
you get more points. I can get more points by actually deleting by having this all on one line. And actually it's a hash to find, so I can't have it on one line. But yeah, I put it all on one line because every character you lose points for, because it's coding golf. So the fewest number of characters wins. Okay? And I've got a pretty average solution. So I do a bunch of stuff you shouldn't do, like for loops, because that is slightly fewer characters than a while. So it's kind of, yeah, no, that's just evil. But, and if you can do the for loop, you should potentially put this inside the for loop and get rid of an extra couple of characters by putting all of this inside the for loop rather than having it an empty for loop and stuff. So there are nasty things you do like this, and then, you know, bitwise operators buried inside the printouts for things, right? This is bad coding. But the thing you see is that you have these test cases. I run a test case and that runs that test case and shows that I was able to walk Thor to the lightning bolt. Yay! And so when you first start, you don't have functional test cases, and so you go through and you fix each of those test cases. So this is an interesting environment to kind of do simple challenges and have a bunch of test cases where you can see what you're trying to achieve. Right? I was considering that we should potentially do this for first year, and instead of having input-output challenges that are done just as like files, we actually make this kind of interface, and we use this specific location to put challenges into, make you guys all have coding game accounts and do some of your coding in here, because how it works is it uses entirely command line input and output. Right? So what happens is you have the console. This is the console output, and Thoravidi, I give it W. I print out the letter W, I print out the letter W, I print out the letter W, and then it gives me more information. Right? So here you can see that I have a for loop that is scanning for, in the for loop there is a print, and I'm incrementing my way, having worked out how far away it is in particular ways. I print out wests and norths and easts, and I print out, so north or blank, and so I can do northwests because I try and minimize the number of times I have to write out N and W, and I only have, although I can go northwest, I can do that by doing a combination of north then west in that particular logic. So yes, it's evil, but it works. Now that's not good programming, right? I don't expect you to do that. That's why I say stay away from golf, right? The other ones are more interesting, I think you'd find. So, though as you said, the temperature ones are solving the problem it requires a little bit of work, but then trying to make it the minimal amount of code is a stupid thing to try and do. There are optimization problems, right? So these are more like debugging, right? So distance simulations, optimizations, reverse engineering, right? So you can do some challenges where okay, it's clear. What's it doing? I think it's yes. I have to go in to solve it first. So and then so you get skeleton code that's doing things, right? And then write the application. Don't forget the training /n for debugging. Use standard error and debug messages. Now this would be for C. You've also got Java, so you guys doing Java, you get the default in Java, and then you could play with it, right? Again, it's command line in and out, and it's a way of kind of playing with code and solving a small challenge to get you better at other languages or see what can be done. And you know, there's community, and you've got all of these test cases you've got to run through, and so progressively you get closer and closer to solution. So this is a nice environment just to play with debugging in. It also gives you like a leaderboard and stuff, so you can see how you're doing and you know, you can pick Norway. So if you want to check, are you the best Norwegian at something? Almost certainly not. I know I'm not the best Norwegian at anything. So, and I'm not the best New Zealander either. So I can pick Norway, and you can see there's someone at 47th is a Norwegian, and they were able to solve in C++ using 4,000 characters this whole problem. Alright, so that's why golf is not a great way of measuring it, because yes, it tries to minimize the length of your things here, completion, but with very few points. So so there are these various environments, various places you can go to learn debugging. Now, an example of debugging. So you had two examples that we have here. So you've got a chess example. So you're saying you've got a chess evaluation function.
Yeah. If you want, I can actually show you the data set.
We can do some examples of practical debugging. And while you do that, you guys have a networking debugging. Yes. So, lots of networking debugging. So one of the things you've got to work on when you're doing networking debugging and any multi-threaded asynchronous debugging is write out all of your data paths and all of the potential sequences. Right? So understand the order in which things can be happening. And particularly if you've got a race condition or you've got drop packets, what happens when a packet gets dropped, what happens when information doesn't get transferred, those sort of things. Right? And you try and find your edge conditions. Right? So you're looking for, and it's true for debug. If you're wanting to find bugs, right? So you think your code works perfectly, look for edge conditions. Right? Go and look for things that are which you think will break your code, right? Or where your code should change its behavior. Try one either side of where that change of behavior should be. Right? So if you've got an array, you always check at the ends of the array, right? On one on that side of it and one on that side of it, what happens? Does your code still work? Yep?
We did try once to do one thing that we expected to break it, and that fixed it.
Haha! Excellent. That can be quite good to have. Like, you're going to try and break it. Actually, Marius found that when writing test cases, right? So one of the things he had is he wrote a bunch of test cases, and one of the test cases was actually succeeding when it should fail, and so his code was passing the test case even though the code was failing, because the error was in the test and then also in the code, and so it looked right, but it was actually wrong because he had like doubled up on his errors. So yeah, this idea of using tests, right? So writing tests tracing through where you expect things to happen can be really useful, showing it to other people. And yes, so we've got the networking one. Trace the paths of execution is often an important role to take. I know one of the coders I knew, when he was coding, he would enter like boundary condition checks as he was coding. Right, he was astoundingly good at this. But most of us aren't good at that. But if you can, put in boundary condition checks into your code so that you know on the edge cases. And one of the interesting debugging techniques you can do, and you guys can do this, if you have command line input, write a random string generating bash script that will just hammer your code with random input. No, it sounds crazy, but it's called monkey testing. So monkey testing is the idea that, you know, if you had a million monkeys bashing away on keyboards, would they break your system? And so I saw this, one of the times I saw this was with a PlayStation 2 developer, so way back in the day. What they did is they actually they hacked their PlayStation controller and they plugged in a serial port and just issued instructions down the PlayStation controller. Just every instruction that could come out of the controller, just completely at random all the time, to see if it would break their menu system. Right, so it was just issuing, you know, right button, left button, joystick, right button, A, Z, right button. So just smash it with events and see what would happen. Right? And they say, you know, they found a large number of small problems and also some game-ending problems by doing that. Right? That no user would normally have got to, except of course when you give it to users and there's 100,000 copies out there, one of those people is going to find it. Right? And so yes, this idea of just hammering your code with a randomly generated strings of stuff or randomly generated events into the user interface on the web page.
Also have a similar version that's called rubber duck debugging.
Rubber duck debugging. Yep. So probably less offensive than monkey. So rubber duck. So right. So this is you're debugging, and so the task here is that you have moves. So these are the number of castles you've done and promotion of pawns.
Yeah.
Yeah. And the number of checkmates you've found, and you've been searching these number of nodes, and this is the number of potential nodes there could be. But we haven't searched all of these.
That's the number of nodes at the single layer that should be in total.
Right, at layer 15.
Huh?
At layer 15 there should be that many nodes.
Yeah.
Okay. And so what you're saying is your evaluation function, if it hasn't evaluated that many things at that level,
then there's a mistake somewhere.
There's a mistake somewhere in the system.
Yeah.
Right. Okay, so this leads to an interesting thing, and this is kind of linked to regression testing, right? So you guys did regression testing in your software engineering?
Don't think so.
Okay, so regression testing, and this is a big thing to do when you're so one of the things to do when you are developing code and also changing code and updating code, and you guys are going to be doing enough edits and refactoring of code, particularly refactoring of code, is not just to set up test cases of what the code should do, right? So one way of doing test cases is you have input and output pairs. And that's why this reminded me of this, because this is like an input and you've got to know an output. When I have an I and an O and they don't match, there's a problem. Okay? So one of the things that you can do while developing your own, while kind of writing your code, to find that a bug exists, right? You might, and something I find really annoying, right? Some of the really annoying bugs are introduced, but you don't find them for a while. So you've made a lot of code, and then you find a bug and go, when did that get introduced? And you check your most recent code, and it never did anything to that. And you check the code, and it never, where did I change this thing, right? And you've got this huge weeks of code you've written, somewhere in there it added the bug. Right? Now, one way to try and manage that is what we call regression testing. And so as soon as you get something that you can generate as a test, right? So you have some sort of input, you put it into your program, and then you record the output of your program. And you say, aha, right, that is a test input with a test output. I'll save that, and I'll rerun it automatically later to check that it still generates the same output. Right? So this idea of, so I go back to things that had been working. So every time I test my program, what I'm doing for regression testing is I'm saving those successful tests as my program applied to a particular input should give a particular output. Right? Now, once it's working, if I know that that's correct, and overnight I run all of my regression tests on my code, I can detect any of these inputs that are now giving me a different output. Right? So here what you've got is you've got something that has a correct answer, right? This input should give you this output. Now, and when you're making changes, you're looking until it fixes it.
Yeah, but there are scenarios that you can get the correct answer, but
The wrong way.
Correct. Yeah.
Yes, you get a number, but you you shouldn't have got the number because how you've done it is wrong, right?
Yeah. There was one thing I did.
Yeah.
I did find other chess programs that has done this, and I could rewrite them, so I can get their output and compare it to mine.
Right.
I did find some issues, but still I wouldn't be able to get them all. I was still struggling with around 50 to 60,000 nodes.
Okay.
But yeah.
So you're one of the problems you've got is how do I find those extra 60,000 nodes?
Yeah.
Right. So for this, by this you're getting 60,000 missing at this level, or
it was at 8 or 9.
8 or 9, right? So in this level you've kind of got a 1 in a million that's
so
being missed.
It was I got it down to around in total 60 nodes, and of those there were around 5 that was wrong.
Okay.
But
So 62 many or 62 few? And you mean 5 that were just actually wrong?
Because what I was doing, I kept changing the input because at first you always have this standard chess layout.
A chess layout, yep.
But you can change them and you can remove and extract pieces and get different results.
Yep.
And by doing so, instead of having, let's say, 84 billion at layer of depth 8,
yep.
I could get that down to around 60,000
Right.
at depth 7. That would help tremendously, because then we just have like 5 arrows.
Yeah, so in here, right, because so one thing to do, and the way I would debug this kind of branch expansion, right, would be to limit it down to, instead of starting from a normal chessboard, you start with a one move to mate, minimum number of pieces, and then start increasing the number of pieces until you found the first time it got it wrong. Okay?
Yeah.
And so you started, so here you'd start with input outputs, and if you know what the output should be, right, then you start from the smallest you can, and then start adding pieces. Right? I would also separate in chess. I'd separate out, rooks and knights and bishops. Maybe there's a bishop rule that you're not doing properly, or a knight rule that you're not doing properly, or there could be castling that you're not doing properly, or so you try and eliminate each one of those rules and see chessboards that can't do this thing and chessboards that can't do this thing. So you build up from instead of from the starting board where you get this massive number, you start with near end boards, which should be mostly giving you a bunch of checkmates and parsing. Now, as you generate these correct things, right, you generate regression tests so that you know with this particular chessboard what output you got, right? And then if you knew that, and if you checked that this was correct, right, you could save that as a test that you'd have in your regression test suite, so that if you didn't update to your program, you'd then run it automatically over all of these to make sure all the ones you knew it should already do, it keeps doing correctly. Right? Because one of the problems is, if you fix one problem over here, if you don't go back and test that you've still solved all of these problems, you fix this one, and those are broken. And then you go and fix some more, and then these are broken, and then you go back there and go, oh, they're broken, and I've changed all of them. How do I fix that? Right? So it's this idea of trying to detect things as soon as they are a bug, detect they're a bug. Now, so I set up, I did regression testing with my PhD thesis, right? So that terrible bit of code actually had some other structures that were quite good about it. So one of the things I did was, because it was input-output, I actually looked at, and I had a regression testing system where, with my program, what I had is I actually had so if I imagine my program is a neural network, it's an artificial neural network, so my program is called NSA, and what I did is I passed it two parameter files and a data file. Right? So I was passing in the pattern file, the network file, and the data file. Right? So that would have passed in, and that would then generate an output file. Okay? And actually I'll change this to F because then I won't have confusion. So if this is function of that equals some output. And that looks like 0, but it is actually out. so it equals an output file. Okay. What I did is I actually changed my output file because I said, well, because I want a regression test and I want to know how I got this output file, what I'll do is F and stack will generate P in D equals P in D out. And I put this in the header of my output file. So basically, instead of just having my output data, I put all the parameters into a header file. I then would accept input of F with P in D out, right? So this is all concatenated into a single file. That all concatenated into a single file would equal P in D out. So if I reran my program on the output of itself, it would regenerate that output. Right? Which means I could just do a simple, well, take this set of files, run my program over that file, see if I generate an exact copy. If I generate an exact copy, my program F is still doing the same job. Right? Now, particularly for me, this was relevant because I would normally, in my parameter file, in this parameter file here, I would not have a seed number. Right? I would seed random from date time. Right? So I'd pick, time, the second down to the second of time and day, use that to seed my random number. So every time I ran this, I would get a new test. But when I did that, I would save the seed into here, so that my random number generator would already have a preset seed. So when I ran it with the seed in here, I wouldn't use I wouldn't seed from time, I would seed from the parameter file, because seed had already been defined in the parameter file, and therefore I'd generate exactly the same output because I have the same random seed, and therefore I'd run through the same process. Which meant two things. One, I could check if I changed something in here, particularly if I was trying to make a piece of code faster, and I wanted it to still give me exactly the same output, just take this time, I would have all of my data. I could just say, for loop, run this over. Every time you run it, check that it's generating the same output file. If it doesn't, something's changed. Right? And I could then go and look in the diff and find out where it had changed and for what set of parameters it would have changed. Right? So this for me, this was a quite simple way of setting up a regression testing system. There are more advanced regression testing systems. When you're using a continuous integration system, you can also set it up to have regression tests built in, right? But this is the idea, this is the kind of principle of having got something working, set some way of automatic checking what you've already got working so that it stays working. So you find the bugs faster. So like most things, this approach has a name for doing these kind of functions. So you may have Runa said he kind of told you this stuff in the database course and on web interfaces. The unipotent so nullipotent and unipotent.
Wait, what?
Nullipotent and unipotent, and idempotent. So if I'll show you the names. Let's go over here and we can put this. So if we go idempotent, so idempotent programming, and if we go to idempotent, so let's see if idempotent. There we go. So idempotent, and I'll add nullipotent. Nullipotent. Right, so nullipotent, and if I make this larger, you'll see nullipotent describes an action which has no side effects. Queries are a typical nullipotent. So when you do so in theory, in a database or on the web, when you do a get, you shouldn't change anything, right? It should be nullipotent. And in a database, if you do a select, it doesn't change any values in the database. You have to do an update or a delete, or a update, delete. What's the other one? Insert. If you do an update, a delete, or an insert, then you change something about the database. But if you just do a select, it's nullipotent. So idempotent is this particular one, which is a unary operation is idempotent if, whenever it's applied twice to any value, it gives the same result as applied once. And by twice or more. Right? So that's where f of x equals f of x. So f of x equals f of x. Right? Now the classic one of this is if you have a database delete, it is idempotent because you have, so if I do delete and I delete, unique ID and I apply that to the database, I say delete item 57, right, with unique ID 57, and then I do immediately again tell it to delete item with unique ID 57, it's still the same database, right? The first time it changed it. The second time, no, you've already deleted that, you've already deleted that, you've already deleted that, I can do that as many times as I like. This is quite interesting operation for network programming, because if you have an idempotent command, right, you can issue it, and if you don't hear anything back, you can just issue it again, right? Because if you happen to get both of them, it doesn't matter, because applying it once is going to be the same as applying it 2 or 3 times. So what you do is in your network communication, you go delete. No, I haven't heard back. Delete. Still haven't heard back. Delete. Oh, yep, delete. Okay. Now I can stop trying to delete that and move on to inserting things. But if I try and insert a user and I go insert Simon, I can't then do insert Simon because then you have inserted 2 Simons, right? So I have to say insert Simon and I have to wait for the acknowledgement before I can progress because I've changed the database more than once. if it was merely a select, it could say select, like, no, tell me that stuff. Don't hear anything back. Come on, tell me that stuff. Don't hear anything. Come on, tell me that stuff. And I can just keep doing that until you give it to me, because it's nullipotent, so it has no side effects. So idempotent has one side effect. Now what I was doing is I turned my function, basically my code, into an idempotent function. Because when I applied the function, right, this f to f of p in d, I would get the same as the output of f of p in d. Right, so I turned it into an idempotent function so I could regression test it. Right? Now, you probably won't hear many people talking about idempotent functions because it has these nice mathematical properties. But when you get into networking and you get into, you know, uncertainty when you're issuing commands, understanding commands that have no side effects and commands that have one side effect but only one side effect versus commands you have to wait for a full acknowledgement, means you can optimize things differently. And also this is this nice function, you can use it as your regression test. Okay? So that principle of once I've got something working, setting up automatic checks that go back and do that idea of regression testing, this is one way of doing that. It's harder to do it with web pages, right? Some of you guys are doing web pages. And so what are you using for your web page testing tool? Do you have a web page testing tool? A front-end testing tool?
Yeah.
Have you thought about front-end testing tools?
I don't think we've gotten that far.
Right, because when we're looking at testing tools, you can, and I know a couple, but if we do front-end web testing tools, I'll see if I can find Codus web information. That's an ad. I don't like ads. Testing tools, front-end developer handbook. The thing is, if I gave you the ones that I was using 2 years ago, they're probably all out of date, so that's better. It's better to search for them now and show you the current ones than it is to just use my memory of what we were using a few years ago. So there are, basically for web development, you've got a couple of things you can do. One is you can record keystrokes. So you click things and you record that you clicked things, and then you play those back to see that you get the same result. Right? So one thing is you have a manual recording of someone doing stuff. The other way is, because say it's a web form, you know it's a form, so you can have filled out versions of that form which you then apply to the web page. When that form pops up, it goes, oh, I recognize that form, I've got these pre-saved values, insert those values and send. And then that's one test done, and then you save presets for actions. So I'll just front-end browser testing tools. There should be some plugins for Chrome as well. Most of them will have like plugins for browsers. So cross-browser testing tools, 7. So we've got 7 cross-browser testing tools. Look to say, you know, can you test these in all the browsers to see that the page is generated, right? So there are various browser testing tools which are more about okay, block, I don't want your notifications. So if we look for, I'm not looking for cross-browser, I'm looking for end-to-end testing framework, Cypress.io. I think that's one of them. So yes, so here you can set up a complete end-to-end testing. So set up testing, write tests, run tests, record tests. Right, so it does the full testing, and so time travel, real-time reloads, Cypress automatic reloads, whatever you make changes to your tests. So so yeah, it is a, so you can look up various testing tools, and you can see companies use these, and I think So yeah, Selenium was one we were using. So Selenium does this, automates the browser testing. So Selenium automates browsers. So that's, yeah. So what do you want the power? It's entirely up to you. Primarily, it's for automating web applications for testing purposes, but it's certainly not limited to that. So the idea is that you can automate your web browser basically and web browser actions, and so you set up tests on the front end web page. So you've got a web page and the Selenium goes in there and then starts doing stuff to it, and you record those and record outputs and get it to do the testing, right? So yep, so as I said, a Firefox add-on. So the Firefox add-on does simple record and playback of instructions. So with the Selenium Firefox plugin, you say, right, record that I clicked this button and I clicked this button and I clicked this button, and then we'll play back those clicks. And I think it does it per item, so it doesn't like record the XY position. It records that you selected that thing and issued that command. Okay? So it gives you this idea of, oh, I'm going to test doing this, and test clicking here, putting my name in, clicking here, putting this in, clicking here, putting this in, clicking OK. Right? Because I'm sure you've done this before when you've tried to test things, yes? And you've sat there writing many times the same thing. I think potentially Froda takes a perverse pleasure in making first years do this. Sitting there typing in the same thing over and over and over and over and over again. You should be scripting that stuff, right? You should never type it more than once. With Selenium, you on a web page, you would record it once, and then that's a recorded script. You go back to the page, you hit the script, it puts it all in, takes you through, fills out all the form the way it's supposed you did it last time, and you see if you get the same result. Right? So that's a way of kind of recording what you do to do regression testing. Right? So if you had, every time you do a test, you put the record on so that you can rerun those tests. Okay, so you get those concepts of debugging. So we're going to be doing this a lot during the semester, and we're going to look at your techniques. When we do code reviews, we'll also do some debug code reviews. So if you and on Fridays, if hopefully when you guys start programming, you will come with some good code for us to try and debug on a Friday. Okay, and we'll debug together.
Golang?
Golang, yeah, I know a bit of Go. I know enough Go to look at Go.
Okay, yeah, because we are dealing with socketing in it, and so that could be fun to look at.
Yeah, there's plenty of challenging stuff in sockets and Go and network asynchronous programming. Okay, so think about regression testing, how you might do it in your environment, how you put wrappers around things, and how you hunt for bugs systematically and try and make sure you find the bug as soon as you create it rather than sometime later. Okay? Good. Have a good weekend.